Bodil Stokke.
I love when people find old bios of mine. Like, at one point, I did actually think I'd write a programming language, and I put that in my bio, and then sort of, I got as far as the parser, and I had sort of a half-assed interpreter, and that was it. But I got a talk out of it, so that's fine. Yeah, so actually, you know, I was going to talk about the perfect language, but if John Hughes gets to steal titles from famous computer science papers, then I'm going to as well. So I'm going to talk about the next make that 7,000 programming languages. Let's be ambitious. No, really, no, really. There's this thing where I really enjoyed writing slides that run in my browser, and there's this thing where I shouldn't be trusted with it. Oops. So the perfect language. What is the perfect language? Oh, come on, you all know, right? Haskell. Yeah? I didn't know where to go from there. So, OK, yes, it's Haskell, obviously. So let's go have drinks. Any contrarian opinions?
Haskell without exceptions.
Haskell without exceptions. That is a very good answer. We're getting what? PHP. PHP. Absolutely. And of course, there's a Lisper in the audience. I would be disappointed otherwise. Yes. Lisp has the perfect syntax, at least, doesn't it? Well, so my hypothesis initially is that there is no such thing as a perfect language. But I think by looking at what we've got, what seems to be working out and what seems to not be working out, we can probably extrapolate what a perfect language might actually look like sometime in the future when somebody actually builds it. So I figured if a language is really popular nowadays, it must mean that it's pretty good, yes. So I found this chart on a page called github.info, which basically tracks the number of repositories on GitHub which use a particular language. And I figure the closer you are to the top of this, the better your language must be. And there are so many gems on this list. Like, Scala developers represent. Woo! Like, you're not omitting it, are you? Yeah. The great new hope for enterprise programming, or JVM programming, or whatever. It's there, 3 places behind CoffeeScript. Closure? Woo! Come on, Closurians, make some noise. Yeah. You're right at the bottom here. I wasn't going to include that much of the table, but I figured I'd have to bring Closure along just so I could point out that you're behind Haskell here. Emacs Lisp, of course. And speaking of Emacs Lisp, this isn't funny. Emacs Lisp is down here, and VimL is way up here with about twice as many repos or more. And I don't really know what to feel about that. Most interestingly, though, perhaps, is that did you know that CSS is a programming language? And it's immensely popular. Well, it is actually Turing complete. But you don't want to go there. It gets a bit complicated. Anyway, so we do, on the other hand, have a very clear winner. Obviously, the closest language we have to perfection has got to be JavaScript. So let's talk about JavaScript. And let's talk about CSS, incidentally. CSS is hard. I'm just going to reload my page, and this is going to go back to being a 50-50 split again. Yes? Right. So let's talk about JavaScript. Can you see this code all the way in the back? I should probably read it out for you. I keep forgetting to increase the font size. So it says x equals 1, and it says y equals 1 less than bang double minus x. And my question for you today is, what does this evaluate to? What is x going to be, and what is y going to be after we run this code? So let's walk through it. I mean, we assign 1 to x, so x will be 1 before we start evaluating y. And then we do a decrement on x, an in-place decrement, which will take x down to 0. And the decrement being in front of the x means that it should return the value after decrementing. So now we're at x is 0. And so the bang does a Boolean inverse. It will cast the value to Boolean first. And 0 should be falsy, I think, in JavaScript. It's very hard to be sure about this in JavaScript. So in that case, we should be at true now. So 1 is less than true. I mean, you might think that is a type error, but this is JavaScript. I believe that is false, though I will not swear to it. So I think we got x is 0 and y is false. Or worst case, y is true. So let's try and run the code and see what is evaluated to. X is 1, y is 1. So remember back in the days before JavaScript was a thing everywhere, where some browsers just didn't know what a script tag was. So the thing you did to make sure that your JavaScript code didn't actually show on page in these browsers would be to immediately after you start your script tag, you put an HTML comment in your JavaScript code, which is why to this day, all JavaScript engines actually support HTML comments. So what you're seeing here is simply x is 1 and y is 1. We can put spaces in there to see what this would actually. Let's just see if, in a better world, if we will write 0 and false. I think that was correct. Good. So that's JavaScript. And I could go on. I can make JavaScript jokes all night if you like. Like 2 plus string 2 is 22, obviously. 2 minus string 2 is 0, obviously. Array 16, this is no joke, I'm sorry. Lol minus 2 plus Batman. Yeah. Ladies and gentlemen, the perfect language. So I got another up-and-coming language I want to show you. Can you tell already? Incidentally, what language is this? Rust. Ooh. So I've been doing a lot of Rust programming recently, and I've been learning a lot about language design from Rust. I'm not going to tell you right now whether I've learned good things or bad things. So I got this little function here called sayHello, which takes a person and wherever the person is from. And it returns a string, oh hi, person from wherever they're from. And I got 2 variables here, Pinky and Ponyville, and you can see where I'm going with this probably. So I want to actually use that function to print this to the console, which means I want to do, I'm included standard out already, so I can probably use that. Standard out has a write method. And so I do the sayHello in the write method. Pinky and Ponyville. Compile. Oh, yeah. So part of the story is I've written this presentation tool in JavaScript. And now I think we've had a disconnect with the server. The server's just crashed and restarted, which means I need to reload the page. Bear with me. This is probably going to happen a couple of times today. So this is my code. It compiles, and it says, oh, yeah. Expected string found &str. So this is a string, yeah? Well, kind of. So obviously it would be too easy if you just had one string type. So the string literals are actually string slices, which are references to basically an array of UTF-8. And this one takes string, so we will need to convert them to strings. And that should sort our problem. And it says write is not in scope, because the write method actually comes from an implementation on standard out of the write trait. A trait is sort of like a type class in Haskell, and you have to import them explicitly to be able to use them. So that should compile. Oh yeah, no. So standard out does write. Write obviously doesn't take a string either. It takes an array of bytes. Fortunately, the string type has a method called asBytes, which will convert the string to an array of bytes. So now, it actually prints "Oh, hi, Pinky from Ponyville." Finally. Let's celebrate by doing it twice. Yeah. It's not that easy. Value used here after move. So Rust does this thing called ownership and borrowing. And it turns out that once we use the string here, it's actually consumed. We no longer own it. We pass ownership to the say-hello function that we called previously. So we can't reuse that one here, because now it's basically out of scope. So what we need to do instead is, instead of taking strings, we should be taking references to strings, so that we just borrow them instead of transferring ownership. Compile that. It tells us that we need to actually pass the references. We need to make those explicit. And finally, it works. Let's celebrate that by printing it 6 times. I know what you're thinking, but no, that actually works. So yeah, this is Rust. This is my life with Rust. It's like, I got these phases with the type checker where first I noticeably deal with my serious types errors, and then they sort of gradually turn into all this stuff with borrowing and needing to cast types into other types and so on. And it's like an internal process, and I feel like I get closer and closer, and I never quite get there until Rust. Yeah, so the thing is, these are actually features. Believe it or not, this is all by design in Rust. And really, believe it or not, these are by design in JavaScript as well. The thing with Rust is it's meant to be close to the metal. It's designed to be a systems language. So every abstraction you introduce to the language has to be zero cost. This is something they're very big on in designing Rust. That So the stuff with ownership and borrowing and whatnot, I'm not going to get into details about it, but it's sort of a replacement, a cost-free replacement for garbage collection. It gives you headaches, but it also does not give you any performance penalty. And this is a theme throughout Rust, as well as being explicit. If you look at Rust code, you should be able to tell from just the code in your general vicinity what is going on. Disregarding side effects, of course, because Rust is not actually a pure language. Still, the thing with where maybe you'd think it would be easier to just not have to put the ampersands in to make a reference. If the function you're calling obviously takes a reference, you could just convert it to a reference. That would be too easy. But the thing is, it's intentional that you should be able to look at the code and know exactly what type is at any particular location. And so I struggle a bit with this as a Rust developer, but I used to be a C developer. Any of you tried doing C development? Remember what that's like? I mean, for all my gripes about Rust, it's a massive, massive improvement on doing systems-level programming with C. And before C, I was doing assembly language, and I don't even want to go there. I'm also not really being fair to Rust, because this is something I'm noticing as I sort of grow more familiar with the language, that the compiler will tell you what's wrong, and you go and fix what's wrong according to the error message. And that's not necessarily the way to get to the best Rust code that you could be writing. Like, look at my previous example. I was taking strings here. And so the string literal is just a reference to str, so I could just actually put those in instead. No need to do any conversion. And instead of fiddling around with that standard out.write, there's actually a macro called print, which will happily take any kind of string-like type that it's able to figure out how to convert into something it can print. So I could just go like this, and that works. And let's try and print it 3 times just to be sure, and that works. So it's a slight improvement. I think of Rust more like a starting point. It's definitely got its warts, its frustrations, but as the standard library grows, as your familiarity with the language grows, it becomes a language that is a lot easier to deal with. It's got metaprogramming, it's got macros. You've got to be careful with macros. Lispers will know what I mean. But it enables you to sort of slowly build a slightly nicer language on top of the base Rust language. I actually had this idea where maybe I could write a transpiler for Rust, because all cool languages have transpilers. From something like, just assume a syntax a bit closer to Haskell, but with Rust semantics. Maybe I could even sort of sneak in garbage collection by default. That would be easy to opt out of, so you can talk to actual Rust code. I think that could actually be a pretty neat language. JavaScript, on the other hand, I'm sure you've heard the story of the birth of JavaScript, where Brendan and I hacked it out in 10 days, frantically, because he'd originally designed a scheme-like language, and it came back down from the powers that be at Netscape saying, nah, we need you to make a language that looks more like Java. And you got 10 days, by the way. And that's how JavaScript was born. And so you can imagine it might have had a couple of design flaws from a process like that. But at first it wasn't even a big deal. Like all the weird coercions with the strings and whatnot that you saw earlier, JavaScript was designed to be this tiny little scripting language that you embedded inside web pages that weren't really doing much more than showing information. It was hypertext back in those days, not single-page web apps. And so if all you want to do is like print a clock counting down to your big launch or whatever we used to do back in those days, then that sort of language was perfectly fine. It did the job splendidly. You didn't need to worry about, if you didn't have to worry about casting to strings all the time, then that was a bonus. Now, obviously, the web kind of grew as we discovered that JavaScript could be used for more than just these tiny little things. And the language didn't. But now that we've finally realized that JavaScript actually would have been better off being a proper language, we are slowly developing it towards an idea of what a modern language should be like. So you've got things like the TC39 committee, which is not redesigning the language from scratch, but adding in modern programming language features. The thing is, the best thing we could do to JavaScript, of course, is to take out the strange bits, like the random casting, the guess what the truthiness of this value is, and all that. But the thing is, if you do that, you're going to break the internet. there are going to be probably millions of web pages that depend on these strange features. And if you just remove them from the language, then the internet stopped working, and that would be unfortunate. JavaScript is a pretty cool compilation target, though. If nothing else, I mean, sure, if you look at JavaScript in isolation, the good parts, it's a half-decent dynamic functional programming language. But right now, at least to me, it's more interesting as something you can compile down to from a more serious language, like, say, PureScript. This basically just looks like Haskell, doesn't it? PureScript is Haskell, but it's strictly evaluated. It inherits semantics from JavaScript more than from Haskell because it actually compiles down to JavaScript. So it doesn't need any particular runtime like GHC.js would to emulate laziness and all the particularities of the Haskell runtime. This is about the simplest program I could find in PureScript. It will do a hello world, basically. See if my compiler is still running. Good. So that it prints hello Joe there. It also returns a function, which my REPL decides to print. And I've had my REPL print out the compiled code for hello world in PureScript, and yeah, there's a lot of it. So the PureScript compiler actually will do a fair amount of dead code elimination. And if I were just using the compiler, then this would go to maybe this entire page and not more than that. What I'm doing here is I'm using Browserify, because I actually wanted to show you a cool tool. So the thing with JavaScript, oops. Did I? No. I want to be on this slide. So the thing with JavaScript that everybody seems to hate nowadays is the sheer amount of tooling that exists. So you've got things like Webpack that you need to learn. You've got things like Babel that you need to learn. You've got ESLint. You've got God knows what else. And it's not just Webpack. There's also Browserify, which is the same thing as Webpack, more or less. There's, have we got any other transpilers than Babel anymore? Did the other ones all die? I remember Google used to have one. Doesn't matter. In addition to ESLint, you've got JSLint, you've got JSHint, you've got probably a ton more. And tooling seems to be what daunts people getting into JavaScript nowadays. And you might very legitimately ask, why does it need all this tooling? But it is, literally, because it's a very strange language. That sort of happened by accident. And given enough tooling, it's actually quite neat. And still, all this tooling is going to give you headaches as a JavaScript developer. But it turns out a lot of it is an added bonus when you're writing compilers to JavaScript. Like this thing that Facebook just released literally a couple of days ago called Prepack, which will take JavaScript code, it will figure out, it's sort of like a minimizer, except it will actually be trying to sort of evaluate and run your code inside a kind of a VM and figure out the minimum program required to actually do the thing that the program you input is going to write. So I ran this output that you just saw, the giant blob of PureScript, through Prepack as well, just for laughs. And it compiles down to console.log hello Joe, which I think is absolutely amazing. And definitely a benefit of being on JavaScript as a compilation target. Though I expect LLVM and the JVM and whatnot will have similar tools. At least it's definitely there. I figured I'd go completely crazy, and a bit inspired by John Hughes this morning, though his was even more elaborate. I figured I'd be doing some sort of piano numbers here, and my own plus function and a Fibonacci using that. And that's going to create a giant mess of ugly JavaScript code coming out of the PScript compiler. And if I run that through prepack, I thought maybe I could get it down to like literally the plus function being just the plus operator in JavaScript. Ambitious as I am. And so prepack will do this. Error. An error occurred while prepacking. See the error logs. Okay, the error logs. It says not an object. Type error. Well, I mean, to be fair, prepack does say what's the word I'm looking for? Pre-alpha, proof of concept, I think is literally what it says on the web page. So I wouldn't expect it to work properly yet. This is fair enough. But I'm excited about where this tool is going to lead. Someday maybe it will compile this to efficient code. Anyway, before I go on, I should probably define where I'm actually going with this talk. I thought maybe I could design the perfect language. And I thought maybe we could just have a look at random language features to try and figure out where the perfect language should go. More importantly, though, do we really need another language? I think this is probably the first question you should be asking yourself if you decide, I'm going to make a language. Who's it going to be for? Why does it need to exist? And if you can't answer any of those, then maybe you should just focus on a different language. On the other hand, I totally want to write this language. So I'm going to tell you what it's going to look like. The guiding principle for my language is going to be, don't make me think. And actually, the most perfect language I could think of looks like this. It reads, hi computer, semicolon, please figure out what I want you to do, comma, then do it, period. Now, I could even make this even better because having done some Erlang, I know that the top complaint about the Erlang syntax is that you have all these confusing commas and semicolons and periods, so let's just remove those. And here you are, the perfect language. Now, go write a compiler for that, please. That's kind of the problem here.
This is why you get stuck after the parser.
Yeah, exactly. So this is perhaps a little bit too ambitious, but I think it alludes to where I want the perfect language to be going, at least, and that is in the direction of more abstraction. I have a quote here, I think. It's not don't repeat yourself, it's don't be the machine. And by that I mean a language needs to be able to, once you figure out a piece of code that is really just machinery, you should be able to abstract it away and focus on actually solving the problem that you're dealing with, rather than figuring out how to do a loop the right way or whatever. My favorite example of abstraction, just gratuitously, is this thing here. So I've written some JavaScript for you. There's a database. It's got ponies and it's got puppies. And I got a vote function, which will vote on whether ponies or puppies are better. Or actually, if you want to vote for something else, then it will accept that too. So I got basically, oh, and look, immutable data structures. I'm basically copying the database before I start modifying it and returning the new database. And so if the database already has the key that I'm voting for, I increment the value stored on that key by 1. Otherwise, I create a new key and add the value 1. So I can go compile first, vote, database, puppies. Oh, and it's immutable. I could be naughty, though, and actually store the result of my vote. Woohoo! Puppies are awesome. But look at this function, though. Do you do this a lot? I find this particular pattern happens all the time in my JavaScript code, where if I got a dictionary of some kind, I want to update a key in a certain way, and if the key isn't there, I need to have a starting value to insert. So I need to check if the key is there and act accordingly. Do you get that a lot? I certainly do. I suspect it looks very familiar to people doing languages with this particular data type. So one of my favorite functions from Haskell is called insert with, which is a function that takes another function, takes a key and a value, and it takes a dictionary or an object. And I'm basically just going to copy this whole thing and modify it slightly. So instead of vote, it's the generalized key. And instead of, oh yes, I'm just going to be naughty and reassign this. This works fine. So if it has the key already, then obj key, this is the tricky bit, is function of obj key and val. Else obj key is just val and return obj. Which means that I can replace this whole thing with the insert with function call, with a simple function that takes two numbers and adds them together. And with my vote and with the number 1, which is the base value that we want to be incrementing by, I'll start out with, and the old database. Now, unless I got type errors I didn't see, then this should be doing the same thing. So this mechanical bit, that occurs a lot in JavaScript code dealing with objects. I've abstracted this away behind a function that lets you provide a function that will get called if you need to modify an existing value and a default value otherwise. And this is a standard function in Haskell's data.map packages. It's not in JavaScript, but I really wish it were. Now, the problem, of course, with JavaScript is if you want to actually change the standard library, first you need to get all the browser vendors to agree, and then you have to push it through committee and wait for all the browsers to catch up. And basically, that's a no-go. But I really wish I could add this function. This is my favorite little example of abstraction. So I got a shopping list for my perfect language. I learned from Rust I actually want to do garbage collection automatically. And adding to that, how about if we automatically dealt with resource management, like say, if you open a file handle, you might want the compiler to make sure that you close it and that you both open and close it only once. I want immutability by default, because if there's one single thing I could think of to put into a language to make it easier to reason about what's going on, it's to make sure that state doesn't change randomly. If you've got a function in a different end of your code base that you pass a value to, that function might mutate the value, and suddenly you don't know what's going on with your local state anymore. I think that's one of the things that closure taught me really well. That and basic functional programming, the value of immutability. High order programming, I just talked about. And this is the fun bit. I want a powerful type system, not just so I can prove correctness, but so I can use the type system as a tool to help me do programming. So instead of in C, where the type system is basically just there to provide hints for the compiler how to produce the most efficient kind of code. I want the types to actually work for me as well, and not just with correctness and autocomplete and whatnot, but what if you could actually use the types to autocomplete code? Here's the fun little thing. I wonder if the compiler has crashed again. No, it's still working. Oh, it works. Yes, so this is a friend of mine, William Bird's recent research project called Barleyman, which is basically an extension of he's got a scheme interpreter written in Minikanran, which is a logic programming DSL, I guess, for scheme, which means that it's not only able to evaluate scheme code using this interpreter, it's also able to take what would be the output of the interpreter and infer what scheme code could produce that output. And it's taken this further into a tool where you can basically have it fill in a function for you. So I guess it's meant to be kind of a TDD tool, because the idea is you have a function called append in this particular case, and it takes 2 arguments, left and right, and I don't know what the contents of that function is going to be. So I can supply some tests. Append. So append the empty list to the empty list should produce the empty list. And then let's run Barleyman to figure out what that function might look like. And it says, well, obviously, it's well, not quite the identity function, but it doesn't really matter because both inputs are the same. It says, given 2 inputs left and right, it's obviously just return the right side, which is the empty list. So that's fair enough. We're probably going to need to supply some more tests. So append list of A to list of B. That should yield list of A and B. Let's crunch that. OK. Oops. Why won't you indent properly, you stupid editor? Right. So this function says if the right-hand side is null, then return the right-hand side, which is null. Otherwise, return list of A and B. And these aren't variables. These are just literals in Lisp. So yeah, I think we still need more tests. Let's go for the whole shebang. List of A, B, and C, list of D, E, and F. That should return list of A, B, C, D, E, F. Let's crunch that. Or actually, so this is a experimental, and it is literally doing a brute force search of the entire problem space. I ran this yesterday. I started it just before I left for dinner. I came back and it was still churning, and I have no idea what the progress looked like. So to make this work, I'm going to need to supply a little bit more, unfortunately. So I know that I'm going to need to have a terminating case for the recursion. But so there's got to be an if statement to check if we're at the terminating case. I'm not quite sure what to check for. But if that is true, then I'm not quite sure what the result should be. And if it's not, then I know I'm going to need to const something onto something else. Let's churn that. Did it work? Did the JavaScript break in the background? No, there we are. So if we're at the base case, if the left-hand list is empty, then we just return the right-hand list. That's correct. Otherwise, we const the car of the left-hand list, that's the head if you don't speak Lisp, to appending the coda, the tail of the left hand, onto the right. So that is basically the append function, right? You, Lisp guy, confirm? Does that look right? I didn't actually add any ability to run this code, but that is the append function. And I've just had a program infer it for me from just, well, a couple of hints here and a couple of tests. That's pretty cool. Now, one theorizes that if we were to add a type system to this, then it would probably be a lot more efficient. And indeed, meet Idris. Idris, if you don't know it, is a dependency type language that looks a little bit like Haskell. The chief difference is that instead of the double colon for types and the single colon for cons, the single colon is for types and the double colon is for cons. Also adds dependent types. So this type signature actually says vector of n of a and vector of m of a returns a vector of n plus m of a. And the vector type is like a list, except it's got a known length on the type level. The length is n and m, and the resulting length thus has to be n plus m for the append. That seems reasonable, doesn't it? So let's ask Idris to add the implementation for us. Boop. Append x's and y's, and then it doesn't quite know what goes in here. Let's split the cases. That is, if I remember my hotkeys for this. So it's able to figure out that because we're dealing with two vectors, we are probably going to be wanting the terminating case and one that matches on the head and the tail of the first list. So that's a good start. Now, given that we don't know what A is, what can go in the first case here? There's literally only one thing that can go in there, isn't there? That's got to be the y's. You might think we could put the empty list in there, but the type signature precludes that. It needs to be something that is the sum of 0 plus the length of y's. And so I can ask Idris, can you guess what this is? And Idris goes, yeah, it's y's. Now for this one, I'm assuming that the same logic holds. There's only one thing that could possibly go in there. I'm going to ask Idris to fill that in for me. And indeed, this is the append function for vectors in Idris. And I literally just hit hotkeys in my Emacs. I didn't do any kind of typing other than the type signature. That's the sort of thing I want to be seeing in my perfect language as a minimum. So that was today's fun with inference. I'm just going to run for the rest of it. I want a language also that is sufficiently low level, by which I mean sometimes I actually want performance, and abstraction and performance don't necessarily go hand in hand. So when I need performance, I want to be able to actually be the mechanic, to drop down and implement my loops myself, or whatever I need to do. Of course, Haskell developers in the audience, what is the traditional response to this? You just need a smarter compiler. It will do this for you. It's been, what, 25 years since Haskell came about, and it's definitely gotten a hell of a lot faster than back then. But Haskell still doesn't really compare with hand-optimized machine code or whatever you might have. Progress is being made, though, and I actually just wanted to plug this thing, because I mentioned this to my friend Nada Amin. How do I make this thing? Ah, there we go. And she said, oh yeah, we're doing research on that. And there's this thing for Scala called lightweight modular staging, which Nada and her colleague made. And I don't actually know any Scala, but I'm reliably informed that this is some very nice high-level code. And this is what it's able to compile to, which I think even I can read. It seems to be just a basic loop. I see the 4 in Scala actually means that there are monads involved, doesn't it? Ah, OK. Well, at least this compiles to this. It says actually down here, but let's not go into that. If you want to check it out, I'm going to provide the link later. Point being, I'm seeing progress, if not an actual solution here yet. What might be a solution, though, is FFI. If you don't know the abbreviation, it's Foreign Function Interfaces, which is a facility usually provided by high-level languages to call out to a lower level language, usually C. C actually also has this facility, most C compilers do, where you can call out actual assembly language if you want. The problem usually has been that you have to write C. I think, though, with a language like Rust, and I know there's been worked on for both Haskell and Node, at least, to use Rust as an easy FFI language, I think maybe this could be a solution for the problem of when you need performance. But I'd like to introduce a different perspective, though. So I've got this idea of what I want from a language, and it's got all the shiny bits. But there are actually other developers in the world as well, I'm coming to realize. And a lot of them, if you show them something like Haskell, they go, yeah, I don't understand this, it's probably fine. But so what can it do that Java can't do? And the answer in the end is nothing. It's just got more interesting ideas. And I think this is a crucial point, because familiarity does matter. And I really do want to introduce all these nifty new ideas to every programmer in the world with my perfect language. But it really does help if the language has a familiar shape. And I think this is where Scala really shines. I managed to find, incidentally, the worst photo of Martin Hradecki on the internet. I'm very proud of this. It's like Ed Miliband and the bacon sandwich. But I think this is something Scala does amazingly well, because the way you sell Scala to a Java developer is basically, it's pretty much Java, except without semicolons. Oh, and it's got a simple build tool. Oh, well. Maybe not that bit. And so you can sort of lure Java developers over to Scala by saving them those crucial bytes, being the semicolons. And then slowly you can start introducing them to functional programming ideas. You can eventually reveal that their for loops are actually monads, and so on. The sky's the limit. Scala is a very powerful language. And it's not a coincidence that it is so familiar to Java developers just naturally, because it started out basically, there was this thing called Team DJ, which introduced generics to Java. That's, what was his name? Dave, Gilad, Marty Mart, and the Unabomber. And they went on after actually launching Java generics in, was that Java 1.5 or 1.6? 1.5, I believe. Or at least two of them went on to do this language called Pizza, which was a superset of Java, which had things like parametric polymorphism, algebraic data types, and basically a lot of things that you only previously seen in languages like Haskell. Of course, as it goes with every boy band, the hot one eventually goes and has a solo career. And this, of course, happened to Team GJ as well, where Martin went off to do Scala. And it was basically just a continuation of the tradition of generic Java to Pizza and now to Scala. But the master plan behind all this is we're going to turn Java developers into Haskell developers. Another thing is you don't want to be teaching too many ideas at once. This is something I definitely learned as a closure enthusiast back in the day, where I could get to the point where I had convinced somebody, usually somebody on the JVM, that they should really go and learn Closure. It's a fantastic, nice, easy-to-learn functional programming language. It's got a lot to offer you. And the question would be, yeah, OK, that sounds cool. What IDE should I use for this? And the answer, obviously, is Emacs. The problem, I mean, it is definitely, I think it's actually still true. 3 or 4 years ago when I was doing Closure, it was basically the only decent choice for any kind of Lisp. It meant, though, that instead of just picking up IntelliJ or whatever they had to go learn Emacs as well. And the thing about Emacs is it's got a bit of a learning curve. It's not just the editor that is completely different from anything else you've seen. It's also that it comes with its own programming language, also a Lisp, that you really kind of do need to learn to be properly productive in Emacs. And so we went from learning Closure to learning both Closure and Emacs. And usually what happened at that point is they just didn't bother learning Closure in the first place. So nowadays we have great IntelliJ plugins and Eclipse plugins, and it's easy to just pick up Closure for a Java developer and go with the tools that you know and not have to actually tackle too steep learning curves. I think that's kind of important. Speaking of tools, and speaking of, oh my God, I spent so much time on this talk. I should, yeah, so there's one final demo that I want to show you. Speaking of tooling, it's not just IDEs, though those are tremendously important, especially if you're writing languages like Java, where not having IDE support is nightmarish. But this is my favorite little time saver and energy saver in any language. Let's see. So I've been watching ELB programmers do programming, and I really, really care about formatting code. I care passionately about whether you use tabs or spaces and how many spaces you do if you use spaces. And if you use tabs, I don't want to talk to you at all. You're a very, very, very evil person. But the thing is, I spend a lot of time thinking about formatting. And I've seen ARM programmers just churn out ARM code without the slightest concern about how they're actually going to format their code. And it looks absolutely atrocious. It sets me off really, really badly. And suddenly they just hit a key in their editor, and a little thing called ARM format runs, and out comes perfectly formatted, perfectly consistently formatted ARM code. And it's all nice. And what that tool actually does, other than save them from having to hit a couple of spaces and enters, is it lets them stop thinking about formatting. And if a piece of tooling can take just the slightest bit of cognitive load off the process of writing your code, then that piece of tooling is actually valuable. And you got something similar in JavaScript. Let's write a really nasty piece of JavaScript code. It's a callback. And it checks, obviously, you've got to check if the error is truthy. Then you return the error as, let's just remove that, as console.log. And this is the bit I really hate about other people's JavaScript code, when they use single quotes. Right. Nice and readable. So I can run this thing called Prettier. And suddenly, that's fine. It's even turned my single quotes into double quotes, and now I can feel good about this code suddenly, without putting any effort into it. Okay, talk faster. Got 4 minutes to go. So another thing, actually I should probably skip this slide. I want to tell you about how amazing NPM is, but if I get into that, I'm going to go for another 10 minutes, and I know you're all waiting for beer. But the point about tooling is tooling can be written for any language. It's not about how well designed the language is. It's got nothing to do with the language design whatsoever. Any language can benefit from tooling. Any language can benefit from something as simple as a pretty printer, although I'm assured by Professor Hughes that it's not a simple problem to solve. But it's a tool that seems very simple on the surface, at least. I don't know, can you pretty print APL? That's something that's been bothering me all day. I think every language will benefit from a pretty printer, but I'm not entirely certain. So what I'm going to do next is I got a number of wild ideas. I told you already about my Rust transpiler. I also thought maybe I could fill the niche between TypeScript and PureScript, where people come and see the PureScript syntax and run away screaming because it doesn't look like JavaScript. I got my prototype language here. This is going to be my second language after Bodil. I'm going to call it Bodil 2. It's a nice, healthy sounding name. It's got basically JavaScript syntax, except I've shortened the function keyword to fn. It's got pattern matching, which I've nicked from a Sweet.js plugin called Sparkler. It's got partial application, Scala style with the underscores. It's got traits like Rust, or type classes like Haskell. I kept the generator functions, the coroutines from ES6, because those are actually quite neat. Algebraic data types, high kind of types, obviously, dependent types, maybe even. I basically just jotted down the syntax for this language, and I've made a start on the parser, so we're nearly there as far as implementation goes. But the thing I did is I user tested this on a friend of mine who has seen PureScript and really, really doesn't like it. She finds the syntax intensely confusing. And she looked at this and she was like, oh yeah, this looks like a great language. I could totally get into this. So this is going to be the future of JavaScript once I get around to it. Another cool idea I had is I want to compile a subset of JavaScript to Erlang. Actually, it's going to need to be a subset of JavaScript plus pattern matching. And the reason I want to do this is, for one thing, I want to trick JavaScript developers into trying out the Beam, which is, well, according to Joe Armstrong anyway, it's the best platform for distributed programming. Also, I think having a JavaScript syntax on top of Erlang will make Joe really, really upset. Yes, I would totally design a programming language just to troll somebody. I know he hates JavaScript, and I know he likes Erlang syntax a lot. And imagine if this became more popular than Erlang itself, he would go mental. It would be beautiful. You think I'm kidding? I got an implementation kind of already. That's JavaScript over there. Compiles to Erlang. It runs. It says, hello, Joe. Anyway, these are great ideas. I would also want to perhaps someday make a serious language. The sort of language that I could actually believe in. And if I'm being honest, that language is probably Idris, and what I should be doing instead is actually focus on tooling for it. For one thing, obviously, we don't have enough text editors already. I'm going to need to write one that is better than all the rest. I'm going to get on that shortly. Something I can do immediately, though, which is going to benefit Idris, and a couple of other interesting languages I've been learning recently, like Pony. I've noted these are all languages with a tremendous amount of promise, but they totally lack package management. And I figured maybe I could just actually write that for them. Not a package manager for Idris or one for Pony, but one that could work for any language that needs one or doesn't have one already. And that's something I'm actually working on right now. That's something I'm being paid to work on right now. So that might actually happen. What you can do next, for one thing, keep looking out for where you can build better abstractions in your language, assuming your language is abstraction friendly. But that should be most of them, especially in this audience. You're all going to be functional programmers, hopefully. Look at your standard libraries, where you could add things, so on. Most importantly, look around you. Look at other programming language communities. Look at the sort of tools they're using, and plagiarize them. Like, if your language doesn't have Elm format at a minimum, you totally should. It's a fun little problem to tackle as well, printing a language. This is my golden rule. You go and you learn at least one new language a year. It doesn't need to be to master levels. Just get to, well, not hello world, but I don't know, a simple problem that you could solve using most of the language. Just to keep yourself up to date, it's also just going to make you a better programmer, just from having a broader perspective on how to do programming. But I think the keeping yourself up to date part is the most important bit here. You'll know interesting new language features. Maybe you can add them to your own language. Or maybe, oh, actually, definitely learn at least one new language a year. Maybe if you don't know it already, consider Emacs Lisp. This is actually me doing Emacs. The true Emacs master is never satisfied with only 10 fingers. Anyway, if you can actually find a niche for your new language, then by all means, you should absolutely go write that language. Don't let naysayers hold you back. That's all I got. Thank you so much. Let's go have beers.